Hello guys, welcome back to another video. I am very excited to show you another example of using this aspect of the chain rule. But before I start, let me just invite you to like and subscribe this page. Okay, so without further ado, we want to differentiate y equals arc sine of x. By the way, arc sine of x is just the other way of saying inverse sine of x, not to be confused with sine to the power of -1. This is inverse sine, okay? So y equals arc sine of x. So we want to find a way to use this little rule to help us express dy dx in terms of x. Well, first of all, if arc sine of x is the inverse of sine, then we can take sines of both sides, right? So I get sine of y is equal to, if I'm taking the sine of the inverse of sine, then the sine and the inverse sine will cancel, leaving us with just x. So in actual fact, x is equal to sine y. That's a horrible n. So we have dx dy is equal to, well, sine differentiates to cos, so that's cos of y, which means that dy dx, well, that's going to be equal to 1 over dx dy. And dx dy, well, that was equal to cos y, so that's 1 over cos y. So that's our dy dx. Problem is, the question says express dy dx in terms of x. So we've got cos y, but we need to express cos y in terms of x. Well, we know that sine y is equal to x. We also know that sine squared y plus cos squared y is equal to 1 using the identity. And if sine x is equal to, if sine y, sorry, is equal to x, then sine squared of y is x squared. So that's x squared plus cos squared of y is 1, which means that cos squared of y is equal to 1 minus x squared. Then that means that, just bringing it up here, cos of y is equal to the square root of 1 minus x squared. So where we had that dy dx was equal to 1 over cos y, well, dy dx is in actual fact 1 over the square root of 1 minus x squared. So that's our final answer. So when y, so the derivative of arc sine of x is in actual fact 1 over the square root of 1 minus x squared. Pretty cool little thing. Definitely more extended version of chain rule because we're mixing and matching other things, but this is a great example. Next, I will show an example where we differentiate one of the other arcs. So let's go for arc cos in another video. Okay, so just another reminder, subscribe. And otherwise, take care, and I will see you in the next video.